Hello, this is Habibpl, and in this section we will discuss the next portion of our chapter number 3, scalars and vectors. Here we will discuss about types of vectors. There are a lot of types of vectors, but we will discuss just 3 which are definitely related to our book. Number 1, that is unit vector. A vector which has direction, unit, but magnitude as 1 unit magnitude. This is called unit vector. And those vectors which has 0 magnitude, they are called null vector or 0 vectors. Negative vector. Let's see the example. Here are 4 magnets, and we know that if the poles of the magnets are opposite, so they attract each other. But this is the second case, that the south is in front of south, so they will oppose each other. They will push back, and they will apply repulsion force. So here the same, that north is in front of each other, and they will apply the opposite force. Let's suppose this magnet is applying a force F1 in this direction. It's shown here, F1. And if we discuss about this one, so we can say that this one magnet is applying the same force F1. Suppose this is applying 5 Newton, as the size of the magnets are same, so let's suppose it's also applying 5 Newton. Now here you can understand very easily that it's very clear that the magnitude 5 are the same, and the unit Newton, they are also the same. But what's the difference between these two vectors, these two forces? That its direction is right to left and its direction is left to right. So this is F1 and this is the same F1 but opposite in direction. So that will be minus vector. This vector is called a negative vector. Now, addition of vectors. We have 2 simple rules to add 2 vectors or more vectors. Number first, that's head to tail rule, and number second, that's by resolution of vector. Addition of vectors by head to tail rule, we can understand by these 2 vectors. Let's put this is vector A and this vector B. If I take this vector with the same direction and same magnitude, just put it here. So you can see over here that this is the tail of vector and this is the head of vector A, and here the B has this tail and this is the head. I put the tail of vector B on the head of vector A. So what's this called? This is just like just wait a minute. That what I've done, I put the tail, the head, if we discuss about this over here, I'm taking this B vector and putting over the head of vector A. So this is head to tail rule. Now what I want to go I want to do there draw a line straight from first vector to the last vector, and the direction is to the end, to the last vector. This is R vector. R means a resultant vector. By this method we can add two vectors. So let's suppose vector A is 3 centimeters, vector B is let's suppose 4 centimeters, but it's not, I'm sure that it will be 3 plus 4 or 7 centimeters. No, it will be about let's suppose 6 centimeters. So our resultant vector will be 6 centimeters. This method of adding two vectors is called addition of vector by head to tail rule. Resolution of vector. I have a pencil. If we switch on our light from upside down, so we will see the shadow of the pencil up to here. And if we switch on from right to left, so we will see that the shade of the pencil is just like of this dark area. Now let's suppose if we if we switch on our both lights, so we will see the shadow over here and here on this wall, and maybe this is the floor. Now I'm drawing over here coordinates, x or y axis, but now this is x axis and that's y axis, positive. Exactly on this place, so then you'll understand very. This is x and this is y. The distance of the pencil from here up to here, this is the shadow on x-axis, and distance from 0 up to here, this is the shadow on y-axis of the pencil. If I call this pencil as a vector, let's suppose f vector, as we discussed before. So I can say that this portion, this distance on x-axis, this is the shadow of vector f along x-axis, and this is the shadow of the same pencil, of the same force, or of the same vector f on y-axis. Here what we done, we have divided f vector into two portions, into two parts, that fx and fy. This is called a resolution of vector, that we resolve our vector into two portions. Okay, now formulas for this chapter, these are: to find fx, just like we wrote over here, that x component of the vector, we have the formula fx is equal to f cosine theta, for y component f sine theta, and for magnitude of any vector we have the formula that f is equal to fx square plus fy square and under root. For direction we can find theta is equal to tangent inverse fy or fx. As a review, if we discuss all these things, so we can say that we discussed today about types of vectors. Number one, unit vector, those vectors which have one magnitude, and they are called unit vectors, and those vectors which have zero magnitude, they are called null or zero vectors. And those vectors which have same magnitude, same unit but opposite in direction, they are called negative vectors. Addition of vectors by two methods, but we discuss about the first one, that addition of vector by head to tail rule. In this method we put the first vector, and on the head of the first vector we put the second vector, and on the head of the second vector we put the third vector, and in the end we draw a straight line from the first vector to the end, to the last vector. In the direction of the resultant vector is to the last vector, and that's called R vector, resultant vector. Resolution of vector, we can resolve, we can divide any vector into two portions, into two coordinates, x-axis, along x-axis and along y-axis. Formulas for this chapter, that's all here. You can learn, you must learn by heart.